Hello guys, welcome to Staad tutorials. In this session I will be discussing about different steel trusses, and this will be the end of the basic steel trusses. In the next classes we will be going to complicated trusses like industrial building versus steel building. So let us begin the session. As you can see, our first figure is this truss. So we go to Start Pro. Select new project, select truss, select some name, and coming to units you can see they are in pounds and feet. So go to feet and pounds, select next, read this, make the spacing as 1 feet, then draw the figure. So you can see 5 5 5 15 feet, so you might need to edit in y direction up to 15 feet. So let us begin. And 4 feet. Now you can switch off the grid. As per our figure you can see we need to add beams. So go to geometry, select add beam, point to point. There is up to the end. Now you can see that all of these are angle. So go to general, define assign profile angle, select add, close, assign to the entire structure, then go to support. You can see both are pinned supports. Assign pinned supports to end nodes, bottom nodes, then go to loads and definitions. The loads are 8,000 pounds and 10,000 pounds. Nodal loads 8,000, positive 8,000 pounds and negative 10,000 pounds. Assign these loads to the particular nodes. You can scale the loads. Now go to design, select code IS 800. Commands will be check code and take off. Assigning both the commands to the entire structure, then going to analysis and print, running analysis. We stay in modeling mode and go to select by specification all failed beams. Since there are no failed beams, we can go to post processing and check the deflection as it goes in X direction. So in this way we are done with figure 1. Now going to figure 2. It's a truss with pinned support and roller support. And 12, 12, 9 feet, which equals 33 feet and 15 feet in y direction. So we'll be doing in the new file, selecting truss. Units are foot and pounds. Selecting front view, you can see I need to edit. In X direction will take 35, in Y direction will take 15. So first in X direction we have gaps at 12, 12 and 9 feet. Twelve, 12, 24 and at 9 feet 33. Select escape. Then in Y direction we have 15 feet and 12 feet. So exactly 15 feet and 12 feet at the other node. Now you can switch off the grid and go to geometry, select add beams, point to point. You can add between 2 points. So we are done with the truss. Now going to general, defining angle property, assigning it to the entire structure, going to supports, pinned support and fixed butt support, which is roller support. Assigning the supports, then going to loads. So we can see the loads are 4000 pounds and 3000 pounds in y direction downwards. So minus 4000 pounds and minus 3000 pounds. So selecting and assigning the loads to particular nodes. Scaling the loads, going to design, selecting our code, defining the commands, check code and take off, assigning the commands to the entire structure. Going to analysis, staying in modeling mode and checking for failed beams. If present, well, these beams are failed. However, we can go to post processing to view the deflection. But in order to rectify the failed beams, we go to modeling in design tab, select commands, select and take off. Now assign these commands to entire structure and run the analysis once again. So now the beams get modified. check. No beams are failed. So in this way we are done. The reactions can also be obtained. Reports. So in this way we are done with these two problems. Now going to the next two problems. Well, you can see this is a beam and these are angle members, but coming to this is a cable member, tensile cable member. So let us see what we will do. Truss, and units are in pounds and feet. So first we'll select front view, and since we have as per our figure 16 feet xward and 12 feet, at least 12 feet ywards, we will select edit 20 and 15. Now first selecting the beam, then selecting the 10 feet and 6 feet angle section, and then comes the cable. Now you can switch off the. So these both are angles, and this is a cable and this is a beam. So we'll do one thing, we'll merge these three. Now we go to general, define, profile, angle, then beam, and then we go to circle, select material steel and give diameter as well. Coming to feet, so let me rectify it once. Just a second. So actually it will be nearly 10 centimeters diameter. So coming to feet, ten centimeter is nearly equals to 4 inches, and so well 10 centimeter will be equal to 0.333 feet. Since 12 inches equals to 1 feet, well 10 centimeter are 4 inches and we have 4 inches, so 4 by 12 will be 1 by 3, which is 0.33 feet. Select add. Okay, we have two dots here. Select add, close. Now assign angle to angle members and assign beam to beam members and assign cable to cable members. This is just cable is just like a circular beam having cross-sectional property and tensile strength. Coming to steel, also circular has cross-sectional area and tensile strength. So now that we are done with profiles, going to supports, you can see both are pinned supports and loads are 4000 and 2000 pounds. So supports, creating support, pinned support and assigning the supports to both the nodes. Then going to loads, assigning loads, you can see downward direction, so minus 2000 pounds and minus 4000 pounds. So assigning the loads, scaling the loads, going to design, selecting the particular code, defining, giving commands, assigning the commands to the entire structure. Now analyzing it, then we check for any failed members if present. Since there are no failed beams, we can go to post processing and check how's the deflection occurring. So you can see the deflection is occurring in this way. Yeah. Now going for our next problem. You can see initially this is inclined at 60 degrees. So let us select new truss, give it some name, foot and pounds as usual. Select next. So now we have 6 feet. So we go edit and select 60 degrees. And we select 6 feet at a gap of 3 feet. Now we go to edit, remove the skew, let us see the dimensions. As you can see, it's been displayed 6 feet, 6 feet is getting doubled. So we'll do a little rectification. We'll just add 0 to 3, then select escape. Now remove the skew. So now we can see that this is 6 meters 6 feet beam. So we select the beam and insert a node exactly at midpoint. Then as per our figure, we need to let us see. We switch out the grid, select geometry, add beam. We need 3 feet this side, so what we'll be doing is or let us first draw this beam, then at 60 degrees we'll be drawing this, and we'll be drawing here this one, then later on we'll be drawing this one. So let us see how that works. Switch on the grid. Well, let us edit this to 20 by 20. Then let us start, since we have 3 plus 2 plus 2 7 feet, exactly somewhere in the middle. So you can see this is 2 feet and 2 feet and 3 feet. Select escape. So now we go to edit, select 60 degrees as per our figure. So it is somewhere gone. Well, we can see so select 60 and let us see what happens. So you can see this ain't working in a good way, since we need to start exactly from the first point. So let us do something else. Well, we have total 6 here, so we go to edit, select 10 by 10 and 0.5 by 0.5 spacing. Now we select edit 60 degrees, select OK. Now we select 0 to 1.5 and 3, then select escape, then we edit and once again let it be 0. So now as you can see, in dimensions 3 feet by 3 feet, we go to edit, select the spacing as 1 feet, and we have now two angles created. Well, let us see what we can do. So there is nothing much we can do here. Okay, one thing I can do it. Well, I got one idea. Select this beam and select the node numbers. So you can see this is the fourth node number. I will go to geometry, select mirror. So coming to plane, well, we need to check which plane it will be. Well, YZ. Okay, node on plane is 4. Select. Okay. So yeah, here we are done. In this way, using mirror command, we have did it. So now we'll go to geometry and add a beam from point to point in this way. So now, since we are done with this beam, we need one more beam. So we'll do one more thing is we'll select beam cursor, select this beam. Once again use mirror at 5. So you can see one more is created, and now you can switch off the grid. Yeah, thank God, we are done. Well, you can renumber the nodes. Before that, you need to select the structure. Sorry, you need to select the nodes. Now now you can see the nodes are renumbered. Okay, whatever the. Well, next, as per our figure, we can see all our angles and supports are a pin support and a roller support, and there are two loads 8000 and 4000. So let us move. Then since we have created a 3 feet beam, mirrored it, but we have here 4 feet and exactly a node point at 2 feet. So what we'll do is select the beam, insert a node, distance will be 2 meters, sorry 2 feet, select OK, close it, select insert node, insertion point is 2 feet, select OK. So now you can see, okay, we have converted this into 1 feet and this into 2 feet. So we'll just merge them, then once again insert a node at a distance 1 feet. Now you can see 2 feet is created. I will delete this part and we'll mirror that part once again in YZ plane along 6th node. So in this way a beam is created. We just renumber those, or else there is no need for renumbering. We can move on. Define assign profile will be angle. Now assigning the property to the entire structure, then going to supports, creating pinned support and fixed bar support, which is a roller support. Now assigning the supports, then going to loads, well, two loads, which is, as you can see, 8000 and 4000. So minus 8000 pounds and minus 4000 pounds. Assigning them to their particular nodes. Scaling them, going to design tab, selecting the particular IS code, defining the commands, check code and take off, then assigning those commands to the entire structure. Now going to analysis, running analysis, then checking for any failed beams. No failed beams. Go on with post processing. Let us see the deflection. How does it occur? So you can see the deflection is this way. Okay, well, we are done with these both problems. Now going to the next problem. Well, these problems looks somewhat different, so we'll be discussing in the next class as well as these problems too. So this is the end of the session. Thank you.